Welcome to Lecture 5. In this video we will talk about functions in C++. There are two major methods of abstraction in C++. The first method is function and the second is objects. If we have a block of code that we use in more than one place, then we can put in a function. On the other hand, in C++ and related languages like Java and C#, we can define an object that groups data which belongs together, along with functions that act on the data. Objects will be covered later in the module. You may have seen some mathematical functions earlier in C++. For example, we have often used functions from the C++ standard library, such as the log of a function or the power of the log of a variable x, or the power function u to the power v. The code of these functions is in the library that we include using the command #include and then cmath. So again, power is the power function, so that w is u to the power v in this example. There are several benefits in using a function. For example, once you've written a code for a function and you've checked that the code is correct, you can use it again without worrying about debugging it and checking that's correct every time you use it. This also hides the details so that you can build larger programs more easily. And the use of functions is known as modular programming. So writing programs that have a skeleton, and in that skeleton calls many different functions that do different jobs. This makes the code much easier to maintain. So the use of modular programming is common across programming languages, including C and C++. It's often good practice to declare a variable to be constant. So if a variable will not change, we can say so. This is done by adding const in front of the variable's declaration. If we try to change a constant variable, we get a compiler error. So for example, this piece of code will not compile. We have constant double p equals 3.14 and so on. Then if we try to change the value of this variable, the code will not compile. We will get a compilation error. The advantages of declaring a variable to be constant are that when reading the code, you know a variable's value just by looking at it when it was first declared. Also, it can make coding safer, because if we try to change something that should not change, we are going to get a compilation error if it is a constant that shouldn't change. And this practice of using const as much as possible and consistently is known as const correctness. Okay, so let's talk about the general layout of a function. This is a function that takes a double x as input and squares it and returns the square. So first of all, we need to specify the return type of the function at the beginning. So this function will return a double, and we declare that at the very first line. Now, one or more arguments are passed to the function inside these round brackets. In this case, we pass a double, which is x. And we declare that to be constant to ensure that x is not going to be changed by the function. Then we can declare another constant double, that's x squared basically, and that's simply x times x. And finally, the code here does the work, and it's all followed in the end by a return statement. So this is the variable that is returned by the function, and the return type should match what we declared here. So x2 is a double, and the function should return a double. In general, this is a pseudocode for how a function layout is structured. So first of all, we have the return type. Now again, this is pseudocode. Don't try and code this up. It's not going to compile, right? First we declare the return type, then we have the function name, then in parentheses we have the arguments, and then we start with braces, and that's the body of the function that does some work, calculates some things, and in the end one of the things that are calculated is a statement, and we are returning this statement. And again, this quantity here has to have a type that matches this, the return type here. Over here. So we have a constant double area. That's the square root of s times s minus a times s minus b times s minus c. And then we return that quantity, that double. And again, this quantity is a double, so the result that this function will return when we call it will be a double. Okay, so when we want to call the function, we call it as follows. So we could define some variables, double x equals 3, double y equals 4, double z equals 5, and then simply declare a constant double a. Or would be to declare multiple functions and then later write out the definitions. In general, it doesn't matter which function calls which other one. So here's an example. So to avoid having to worry about which function calls which one, and I can simply declare all the functions at the beginning. So here I have a double cube function and a double square function. Then I have my main function, and then in the end I define all of these. So this is a double cube, and the cube actually uses the square function, but now that's okay because I have already declared the square function earlier on. And then I have the double square function. Now this definition may come after the cube, but now that's okay because I have already declared the square and the cube at the very beginning of my program. So although the definition of square comes later, it's the declaration is enough for this code to work. I have declared the function square here, and so the compiler will recognize it here and can use it. Simply we just have to define the function later on, but the code will work. Now, just to give a few more examples of functions, here are 3 different functions that do different things. So the first is a function where the return type is a bool, and the function is called isEven, and the input or the argument of a function is an integer, m. And the function will return the modulo of m modulo 2. So if m modulo 2 is 0, that means that the number m is divisible by 2, so that number is even. If that number is even, then m modulo 2 is 0. So that the result of this function will be 0. In other words, it will be true. So the Boolean variable can be 0 or 1. It's 0 if it's true and 1 if it's false. So in this case, is even, the answer is true if m is divisible by 0, or sorry, if m is divisible by 2. Okay, so here's another Boolean function. Again, the return type is a bool, and the function name is self-evident, is all equal. So are these arguments all equal? So this function answers that question. So we have 3 arguments, a, b, and c, which are all integers, and then this function will check if a is equal to b, and a is equal to c, and b is equal to c. If all of these statements are true, then this function will return 0, which is true. If any of these is false, then the combination of these statements will be false, and then this Boolean variable will be false. So this function will return false. And finally, here's another function that returns the maximum of x and y. So here I input 2 integers, x and y. Those are the arguments of my function. And there's an if statement that compares them. And if x is greater than y, it returns x. Otherwise, it returns y. And here, again, I have input that are integers and output that's an integer. So that will simply return the maximum of the 2 numbers that I provide as input. Now we can write a program that compiles all these 3 functions. So here's a program. I have a main function, and it does some work, and then there's a while loop. And the statement that the while loop has to check uses the function isEven. So while n is even, it will keep working on this loop. If n is odd, then the loop will end. And then we will read, this is cin, so that will read a variable n from the keyboard. And then we have an if statement here that if x, y, and z are equal, then it will do something. And in the end, we print out of the screen the maximum of p and q, let's say, where p and q have been calculated somewhere here, and x, y, and z have been calculated somewhere here. So this is an example of how we might use these three different functions in one program. But this is just an example, an illustration. Sometimes we may not want to return a value. In that case, we can use void as the return type. So, for example, this function, output square, it can take x as argument, calculate the square, and print it to the screen. But it will not return it as a mathematical, so it's not a mathematical function in this sense. It's a C++ function, it's a programming function, but it's not a mathematical function. So it will not return anything. It's not equal to anything. So it will return nothing. So I can use void here to specify that this function doesn't return anything. Now, again, this is a programming function, so it will do some things. In this particular case, it will calculate the square and print it to the screen, but it will not return it. So if I call this function, I can have some number y here that's equal to 3, let's say, and then I want to output y squared to the screen, then I would call this function. This function I would pass this argument y to that function, that will calculate the square, print it to the screen, but it will not return y squared. So I can't say here that y2 equals output square of y, because if I try that, then y would be equal to nothing. No, because this function doesn't return any number. It does some things, it prints that number to the screen, but it doesn't return a number. So it's not really a mathematical function. I cannot use it that way. It only does certain things and prints things to the screen, calculates things, but it doesn't return anything. So the return type is a void here. Sometimes a function may have no arguments. So it's not necessary actually for a function to have any arguments. In that case, we can simply skip and not put anything inside the round brackets. So, for example, this function has no argument. It does not need any input, and it just returns the value of p or pi. So we still have to specify the return type, which is a double. So it has 16 digits of accuracy, but it doesn't need any input. So the round brackets here are empty. And this will simply return the value of p. And then I can just call this function, and when I call it, I have to be mindful and use the round brackets here, but I will not need to put any argument in here. So here I can just say constant double x equals get p, and then that will call that function, which will return the value of p, and it will set it equal to x, and this is it. One could also put void when declaring and defining the function. So when calling the function, we still have the parentheses that are empty, but I could put void here when I'm declaring and defining the function, just to be clear that there is no argument here. So in this case, it will return the Euler constant, the number e, or e to the first power. Okay, to summarize, in general, functions should do one logical thing. The name of the function should be informative, and it's best if the code for each single function is not too long. For example, it's not longer than a PC screen. And if we follow these rules, that will allow us to write modular programs that are easy to write and easy to maintain later when we want to modify them and use them. Thank you for watching. I'll see you in the next video.